Hello there and welcome to a brand new lesson. This is How Beyond Numbers, where we learn maths the easy way. In this lesson, we are looking at the remainder and the factor theorem. By the end of this lesson, you should be able to state and apply the remainder theorem and the factor theorem. You should be able to also use the theorems to find remainders without long division. You should be able to use the theorem to check if an expression is a factor, and also use the factor theorem to find unknown coefficients in polynomials. Here are some vocabularies we'll be using as we proceed, and I advise you pause at this moment and quickly take a glance before we continue. Without much I say or do, let's quickly look into it. Now let's start by first of all understanding these two theorems. With the remainder theorem, if we have a polynomial, let's say p of x, and we want to divide it by another polynomial, so let's say divided by the polynomial, let's just take x minus a. Now, after our long division, that is using the long division method, we actually get a remainder, you see. So just for illustration purpose, let's take the polynomial we have here, that is x cubed minus 2x plus 5. And then we want to divide it by x minus 2. From our previous lesson, we learned we need to have a descending order of the index notation. So there is 3 here, we need 2 here, and then we need 1 here as well. So all I'm just coming to do is to extend this and then bring a 0x squared. So plus a 0x squared. So with this, we can do our division. So we have x into x cubed, which gives us an x squared. X times x squared gives us an x cubed. Then we have negative 2 times x squared. That gives us a negative 2x squared. If you have to subtract, I'm going fast because we've actually done this already, and then we are just using it for illustration purpose. So 0 minus negative 2 gives us a 2x. So we have a 2x squared, then minus a 2x plus 5. If you have to divide with the x once again, x into 2x squared, we have a positive 2x. Then x times 2x gives us a 2x squared. Negative 2 times 2x, that gives us a negative 4x. If we want to subtract, what do we get? Negative 2 minus negative 4 gives us a 2x. So we have our 2x and then plus the 5. For the last time, we have x into 2x. That gives us a positive 2. X times 2 gives us a 2x. Then negative 2 times 4. That gives us a negative 2 times 2. That gives us a negative 4. If we subtract, what do we have left? We have 5 minus 4. And that gives us a 9. And we also said that if the degree of the leading coefficient here, if the degree is greater than that we have here, we don't continue. That is our stopping criteria. Hence, we would have to stop over here. Now, this simply means that if you are to divide x cubed minus 2x plus 5 all over x minus 2, then you are going to get a quotient, which is the x squared plus 2x plus 2. And then plus our remainder. This is our remainder over here. So our remainder is 9 all over the divisor, which is our x minus 2. Now, what if we actually want only the remainder, this remainder over here, but then we don't want to do all this long division before we can get our remainder? That is where the remainder theorem comes into play. So the remainder theorem simply says that if you have a function, let's say p of x, which is a function in terms of x. Now, if you want to divide it by another function, let's say an x minus a. To get its remainder, all you want to do is find p of a. If you're able to find p of a, that gives you the remainder. You see, so p of a actually gives you the remainder. And how do we get the a? The function you want to divide by, that is your divisor, what you want to do is you want to equate it to 0. So if you equate it to 0, you have your x being equal to a. You're able to make x the subject in the divisor. You just substitute it into your function, and that gives you your remainder. So if you have to come back to what we did here, we divided x cubed minus 2x plus 5. We divided it by x minus 2. But this time around, all we want is the remainder. What will be left? So the factor theorem is saying that for what we have here as our divisor, let's equate it to 0. So if you equate it to 0, you are going to get our x, which is equal to 2. Then for this particular function, let's call it the function p of x, given by x cubed minus 2x and then plus 5. All we need to do is to substitute this x into the function. So that wherever we see x, we are going to put 2 there. So this simply means we have our p of x, which we have said is x cubed minus 2x plus 5. And hence, let's find p of 2. We are putting 2 in place of x. And by so doing, we have 2 to the power 3 minus 2 into bracket 2, then plus our 5. Simplifying, we have our p of 2. That gives us 2 to the power 3. That is an 8. So 8, 2 times 4. That gives us a 4, then plus 5. Simplifying further, we have 8 minus 4, which gives us a 4. Then 4 plus 5. That gives us a 9. What do you observe? You realize that when we made x the subject from our divisor, and we had x equals 2, and we substituted that 2 into the function, we had 9. This 9 is the same 9 we had here as the remainder of our division process. You see, and that is what we wrote here. This is what we call the remainder theorem. So rather than going through all the steps needed to get a remainder, the remainder theorem provides a very simple method to get our remainder without necessarily going through a long division. It says find the remainder instantly by what? Substituting your x equals a. That is making a the subject from the divisor, and that will give you the remainder. Now there is another theorem that is derived from the remainder theorem. We call that the factor theorem. So all the factor theorem is saying is anytime we use the remainder theorem and we get 0, then it simply means the divisor we had is actually a factor of the polynomial. For instance, let's say we want to divide the polynomial p of x, where p of x is x cubed, then minus 4x squared plus x plus 6. We are dividing it by another function, let's say d of x, which is given as x minus 3. So just as we have always done, if you wanted to use the long division, then we would have our x minus 3 here, and then we have our x to the power 3 minus 4x squared plus x plus 6. If you are new to this, you can quickly check on the playlist where I have treated this in depth. So after this, we then do our long division. X divides x cubed, that is x to the power 2. If you multiply, you are going to get x to the power 3. Negative 3 times x squared, that gives us a negative 3x squared. If you have to subtract, We are going to get a negative 4 minus negative 3. That gives us a negative 4 plus 3, which is a negative x squared. This, we said, always cancels out. So we have plus x plus 6. We proceed again. So x into x squared, how many times? That is an x. So with that, we have a x times x. That gives us an x squared. Then negative 3 times negative x, which gives us a positive 3x, after which we do our subtraction. So if we subtract, we have x minus positive 3. That gives us a negative 2x. Then we have our plus 6. We do it one more time. X into negative 2x, how many times? That is a negative 2. So x times negative 2 gives us a negative 2x. The negative 3 times negative 2 also gives us a positive 6. Now, if you have to subtract, you have 6 minus 6, which gives us a 0. Then negative 2x minus negative 2x, that also gives us a 0. The remainder after our division was what? 0. Now, from normal arithmetic operations, that is the division, if you divide 6 by 3, what would our quotient be? Our quotient is going to be 2, with a remainder of what? 0. This is to tell you that 3 divides 6 perfectly with no remainder. In other words, 6 is divisible by 3, and hence 3 is a factor of 6. The factor theorem is saying that anytime we do our long division and we get a remainder of 0, then it simply means what we use as our divisor is actually a factor of the polynomial. So since now we know how to also find the remainder, that is using the remainder theorem, then anytime we want to determine whether or not a particular function is a factor of the other, we simply apply the remainder theorem, and then we check our answer to see whether or not it is equal to 0, and then we can confirm or conclude that it is a factor. So if we wanted to use the remainder theorem here, our function p of x is simply x cubed minus 4x squared plus x plus 6. So with this, our d of x was giving us x minus 3. So all we need to do is to equate this to 0. So x minus 3 is equal to 0. Making x the subject, we have our x, which is equal to what? 3. Hence, we'll be solving for p of 3. And p of 3 simply means anytime we see our x, let's substitute 3 into that. So we have 3 cubed minus 4 into bracket 3 squared plus 3, then plus 6. So 3 cubed gives us a 27. So we have 27 minus 4 into brackets 3 squared. That gives us a 9. Then plus 3 plus 6 gives us a positive 9. Simplifying, we have our 27. Negative 4 times 9 gives us a negative 36. So negative 36 plus 9. Negative, that is 27 minus 36 gives us a negative 9. So we have negative 9, then plus a 9, which then gives us a 0. What did we use to test? D of x, which was x minus 3. And what was our remainder? We had what? 0. So it simply implies that x minus 3 is a factor. You see, and there was no need doing the long division we did here, but we just applied the factor theorem to find the remainder. You see, so now that we know what all this is all about, and then we know the importance of the factor and then the remainder theorem, which is that it helps us avoid this long calculations or the long division. Let's now look at how we can apply them to solve some questions. So with that said, let's look at our first example we have here. It says find the remainder when p of x is given as x cubed minus 4x squared plus 3 minus 2 is divided by x minus 3. All we want is the remainder. So we wouldn't go and then use the long division. So we're given p of x to be equal to what? X cubed, then minus 4x squared plus 3x minus 2. And we are dividing it by what? X minus 3. So we are dividing by x minus 3. So all we need to do is to let x minus 3 be equal to what? 0. Now if x minus 3 is equal to 0, then it simply implies the value of our x is equal to 3. Hence, let's find p of 3. That is using the remainder theorem. Using the remainder theorem, we are going to say p of 3 then is equal to the remainder, which is 3 cubed minus 4 into bracket 3 squared plus 3 into bracket 3, then minus 2. So all we want to do is to find p of x at x equals 3. So with that, we have 3 raised to the power 3, which then gives us a 27. Then minus 4 into bracket 3 squared gives us a 9. Then plus 3 times 3 gives us a 9 minus 2. We have 27. 4 times 9, that gives us a negative 36. Then 9 minus 2 gives us what? A 7. You see? So all we need to do is to solve further. 27 minus 36 plus 7. That gives us negative 2. You see? So we can simply say, therefore, the remainder is negative 2. And no long division was even needed over here. So that would simply be our remainder. Let's look at an example where the remainder is actually x plus a. So this was a minus. Let's look at the one that it is a plus. So in this second example we have, it says find the remainder when p of x is divided by what? X plus 1. So our p of x is giving us 2x cubed, then minus 3x squared plus x minus 5. This is. Then it is being divided by x plus 1. So all we need to do is to let our x plus 1 be equal to 0. If x plus 1 is equal to 0, making x the subject, our x is simply negative 1. So what do we use now? We use the remainder theorem. So using the remainder theorem, we are going to get the p of negative 1. You see? So p of negative 1 is simply 2 into bracket negative 1 cube, then minus 3 into bracket negative 1 squared, then plus negative 1, and then minus 5. Simplifying, we have 2 into bracket. You know, if you have a negative number raised to an odd number, the answer is going to be a negative. So 2 raised to 2 into bracket negative 1, then minus 3 into bracket 1. Then this is giving us a negative 1 minus 5. Simplifying further, we have 2 times negative 1, that gives us a negative 2. Negative 3 times negative 1, we have a negative 3. Then negative 1 minus 5, that gives us a negative 6. Simplifying, we have what? A negative 11 as our final answer. So it simply means if we are to divide this function by this, even using the long division, the remainder we are to expect is what? Negative 11. As simple as that. So now that we know how to find the remainder, let's add a little bit of factor theorem to it. In our next question, we'll be checking for the factor of a polynomial. So our example number 3 says we should show that x plus 2 is a factor of p of x, which is equal to x cubed plus 5x squared plus 8x plus 4. So we have our p of x being equal to the x cubed, then plus 5x squared plus 8x plus 4. And the factor we want to use is what? X plus 2. You see? So we should simply let our x plus 2 be equal to 0. And that will imply that our x is negative 2. So using the factor theorem, we know that x plus 2 is a factor if and only if the function p at x equals negative 2 gives us a 0. So then we would have to do our substitution and then confirm whether or not we are going to get a 0. Hence, our p of negative 2 simply gives us anywhere we see our x. Let's substitute that with what? Negative 2. So we have x being negative 2 all cubed plus 5 into bracket negative 2 all squared plus 8 into bracket negative 2 then plus the 4. Simplifying further, we have negative 2 cubed. That gives us a negative 8. Then plus 5 into bracket negative 2 squared. Negative 2 squared is simply a 4. Then 8 times negative 2. That gives us a negative 16, and we have our plus 4. Simplifying further, we have negative 8, then 5 times 4 giving us a 20, minus 16 plus 4. So we could also say the negative 16 plus 4 gives us a negative 20. 8, that is a negative 8 plus 20 gives us a 12. 12 minus 12 gives us a 0. As you can see, since p of negative 2 equals 0, then by the factor theorem, we can conclude that x plus 2 is a factor of p of x. So we can conclude by saying, hence, we have our condition stated over here. So we say, hence, x plus 2 is a factor. And that is all. Very simple, isn't it? Now, you could also be asked to find an unknown coefficient using this same set of principles. Let's look at how we can apply this to find unknown coefficients. Now, let's look at this fourth question. It says, p of x is giving us x cubed plus ax squared minus 7 plus 6. Given that x minus 1 is a factor, find a. How do we go about this? So first of all, we have p of x being given as x cubed plus ax squared minus a 7x and then plus 6. Now, from the factor theorem, if x minus 1 is a factor, which implies that our x is equal to 1, then that also implies that if we evaluate p of x at 1, we are supposed to get a 0. You see? So substituting 1 for our x, we are going to say, then our p of 1 is simply a 1 cubed plus a into bracket 1 squared minus 7 into bracket 1 plus 6. Simplifying this, we have our p of 1 being equal to what? 1 plus a minus 7 plus 6. That is a cubed gives us a 1. Then a into bracket a squared gives us a times 1, which is a. Negative 7 times 1, we have a negative 7. Then we have this 6 as well over here. And we were told p of x should give us a 0 because it is a factor. So all this is equal to 0. Is equal to 0. Simplifying, we have a, then 1 minus 7 simply gives us what? A negative 6. So negative 6 plus 6 is equal to 0. We have a, which is negative 6 plus 6 gives us 0. So a is equal to what? 0. As simple as that. So it simply means if our a is equal to 0, if our a is equal to 0, then the polynomial p of x is actually equal to x cubed minus 7x plus 6. You know it's minus 7x plus 6. We have our p of x, which is equal to x cubed plus ax minus 7x plus 6. But then the a is 0. So if a is 0, if 0 is a coefficient of any variable at all, it brings it down to 0. Hence, we have our x cubed. And since we are not going to write this again because it is 0, we have minus 7x and then plus 6. This is a simplified expression. So we can also apply the factor and then the remainder theorem even to solve an unknown. And we can even solve an which can also lead to two unknowns. So that is going to be our last question. That is solving for two unknowns, and then we can call it a day. So for our last question we have here, it says when p of x, which is given by this function, is divided by x minus 2, the remainder is 4. And when it is divided by x plus 1, the remainder is negative 14. You have to find p and then kill. How do we go about this? You can, since we've done a whole lot, you can pause at this point and then even try on your own so that you come and then look at the suggested solution. So you have p of x being equal to x cubed, then plus p x squared plus a kill x minus 10. Now, if x minus 2 is a factor, then it simply implies that our x is equal to what? 2. That is making x the subject. And we're told p of this being a factor, so p of 2 equals 4. We have our 4. And substituting into our p of x, then we are going to say p of 2, which is 2 to the power 3 plus p of 2 squared, and then plus a kill into brackets 2 minus 10 should be equal to 4. Simplifying further, what do we have? 2 to the power 3 gives us an 8. So 8, then plus, this gives us a 4p, then plus 2 kill minus 10 is equal to 4. Making your p and then kill to be at the left hand side. You now have a 4p plus 2 kill, which is equal to a 4 minus 8 plus 10. 4 minus 8 gives us a negative 4. So negative 4 plus 10 gives us a 6. So let's simplify that and simply write a 6. Now, since they are all even, if we want to simplify our equation, we can divide each and every term by 2. If we divide each and every term by 2, we have a 2p plus a kill, which is equal to a 3. So we name this as our equation 1. Now we follow the same procedure to solve for equation 2. For equation 2, we are told that if the function p of x is divided by x plus 1, we get a remainder of what? -4. So that means that we should let x plus 1 be equal to 0. If x plus 1 is equal to 0, then it simply implies x is equal to -1. And if we have to solve for p of -1, we are going to get what? -14. Hence, for p of x over here, let's do the substitution. So we have p of -1, which then gives us x raised to the power 3. So that is -1 raised to the power 3, then plus px squared. So p into brackets -1 squared, then plus kill into brackets -1, and then minus 10. And all this gives us a -14. So simplifying, we have -1 raised to the power 3, which is a -1. Then 1 plus p into bracket -1 squared gives us a p. Then kill times -1 gives us a negative kill, and then minus 10. And all that is equal to -14. So making p minus q the subject, we have -14 plus 1 and then plus 10, which is equal to p plus q. So with that, we have our -14 plus 1, which is a -13. -13 plus 10, that gives us a -3. So -3 equals p plus q. So this becomes our equation 2, which we can even simply write it as p plus q is equal to what? -3. So this is our equation 2. So we have our equation 1. Let me just bring that here. And then we also have our equation 2. Now you just have to solve simultaneously, and that is all. Now, just by observing it, I think the elimination method would work here. So all I'm going to say is equation 1, then plus equation 2. We are adding all together. If we add, realize that the kills vanish, you see. So with that, we are going to get 3 minus 3 plus, so since we are adding, so 3 plus -3, that gives us a 0. Then kill plus -kill also gives us a 0. Then we have 2p plus p, that gives us a 3p. Now it is obvious that this can only be true if our p is equal to 0. If you have your p to be 0, you can put p in any of the equations. So let's put p into what? Equation 2. And equation 2 was p minus q equals -3. Doing our substitution, we'll then say we have 0 minus q, which is equal to -3. And our negative q is equal to -3. And then q is equal to what? 3. As simple as that. So we've been able to find or solve for both p and then q. So therefore, p is equal to 0, and then the q is equal to 3. Now that implies that the p of x, which was given as x cubed plus px squared, then plus q x minus 10, is actually going to be an x cubed. Then since p is 0, it simply means this particular term is going to go off, because 0 times whatever we have in x will give us 0. Then plus our q, which is a 3x, then minus 10. That is going to be our p of x. As simple as that. This brings us to the end of this lesson. I do hope it was helpful. As usual, I'll leave you some exercises so you try on your own just to test your understanding. So here are 5 exercises you can try on your own just to test your understanding. They just follow the same procedure we used in solving these examples. This Hub Beyond Numbers where we learn maths the easy way. If this is your first time on this channel and you think it will be of help to you, you can choose to subscribe if you so do it, so that anytime I release a video, you'll be notified as well. See you in our next lesson, where we'll be looking at how to apply the factor and then the remainder theorem to solve or factorize polynomials, specifically cubic polynomials. Bye for now and do stay safe.